to be able to go through and read a statement, whatever that statement is. Here we got two angles that are vertical angles, have equal measures. Now, you may have gotten, there's like 4 or 5 different questions that everybody kind of pulled from. So maybe in this class, 5 people got this one. 5 other people got this one, 5 other people got this one. Okay? But they're all kind of the same type of question. They want you to be able to take that statement and see if we can write it as an if-then statement. Okay? So basically, we're going to rewrite that, putting the words if and then in there. But hopefully, do it so that we don't lose any conceptual ideas of what's going on there. Okay? So, we're talking about two angles being vertical and having equal measures, right? Okay? So, would you agree that if we wrote as the conditional, if two angles are vertical, then they have equal measures? Would that be okay?
Yeah.
Okay. So when we write our statement, we want to make sure that it does become an if-then statement, but it also encapsulates the concept that they're saying here. Now, they gave you the option of choosing, right? It was like 3 or 4 things that you had to click from. So hopefully find that one that mimics that. Okay. Part B says if the conditional statement is true, write the converse of the conditional. Okay, so that is true. So let's write the converse. If you remember, the converse is taking the if part and the then part and just flip-flopping them. Okay, so if I'm gonna still should probably write 2 angles here. I'm still going to say 2 angles here. If 2 angles have now equal measures. Okay, now putting this conclusion part in my hypothesis, then now put this hypothesis as your conclusion down here. So then 2 angles are vertical. Okay, now understand what that's saying. If this is going to be a true statement, they're saying every time you have 2 equal angles, every time that happens, you close your eyes and put equal angles in your hands. You can tell me that they're vertical. Okay? That's what that's saying. If we agree that this is a true statement. Okay? Would you agree with that? It's a situation every time? Every time that there are 2 equal angles, 2 angles that have equal measurements, no matter where they are. Okay? No matter how they're presented to you, if they have equal measures, they have to be vertical. Is that true or false? That's false, right? Okay. There are some other situations that could arise in which you have equal angle measurements, but they not be vertical. Okay? So this is false. Now the rest of the question, part C, says that the conditional statement is false. Give a counter example. Well, we just got to hit that there's an option that says it was true. So click the true statement, or it'll say the conditional was true, so there are no counter examples or something like that. Part D says if the converse statement is true, write a true biconditional statement. Well, it wasn't true. So you click the option that says the converse was not true, I cannot write a biconditional. Okay, and then it gets you down to part E. And part E is actually tied directly to us being able to answer whether the converse was true or false. Okay? Part E is asking, what is that counterexample? Okay? What is a situation in which you could definitively say, when I have 2 equal measurements, those angles are not necessarily vertical. Okay? Because first thing I want you guys to understand is this true sometimes? Yeah. When they're vertical angles, they are equal, right? So if I give you 2 equal angles and they just happen to be vertical, then yes, that's a true statement. If I give you 2 equal angles, couldn't one of those angles be something like this? Couldn't we look at maybe a picture that looks like that, where both those angles are maybe both 90 degrees? Would they be equal? Are they vertical there?
Yeah.
No, those are a linear pair there. Okay. Remember what vertical meant, and this is another aspect of being able to answer questions like this. Vertical meant if I've got 2 lines intersecting like that angle there and that angle there are vertical. Okay. These are not. Okay. So every time we come across a statement, whether we want to determine whether it's true or false, what we have to do is think about the infinite number of possibilities on how that statement can occur. And then how that statement occurs, can I answer those as true or false? Okay? If I can answer every infinite possibility as being true, okay? For instance, that first question. The first conditional. If I go back to, because we answered it as true, right? Okay? If two angles are vertical, okay, then they have equal measures. What that is saying is that every single time, the infinite amount of different times that you get different vertical angles, okay? You draw a vertical angle in front of you, two vertical angles in front of you. You erase it. You draw another set of vertical angles. You erase it. You draw another set of vertical angles. Okay? Every single time you do that, they should have equal measures. That makes sense? And that should be true. We can do that every single time we have vertical angles. They're always going to be equal measures. Okay? When it's false, okay, what it's saying is that there is at least one time where that would not happen. Okay? You're saying if two angles have equal measures and two angles are vertical. Okay? There is at least one situation where this does not happen. And there's actually, in this case, a lot of situations. But what they do is they narrow it down for you. Okay? They say the converse statement is true. So you obviously know it's not C. A and B have got to be the answers. We know the converse is false. Okay? So we're giving you one counter example here. So let's just look at these pictures. It says right angles and a rectangle. Okay? Right angles and a rectangle. Would you consider right angles and a rectangle as having equal measurements? Okay? But not being vertical?
Yeah.
Okay. So that's what this is said. If this was... Let me put a rectangle up here. Okay, those are all, I'm not going to put the markings in there, but those are all right angles. They're all the same. Okay? What this is saying, if we were to say this was true, okay, if this was a true converse, if two angles have equal measures, so if I said this angle here and that angle there were the same, okay, you would be able to tell me that those two angles were vertical. Does that make sense? If that statement was true. We know those are not vertical, right? So that's why that statement's false. Okay? The part B says a right angle and an acute angle. Okay? Well, I'm not going to choose a right angle and acute angle. Okay? Because the first thing I have to do, I don't know why my, let me plug this in real quick. The first thing we have to do in order to say whether this statement is true or false is that when I try to develop a counter example, my counter example first has to satisfy that condition. I have to have angles that are equal. Does that make sense? Okay. Well, is a right angle ever going to be equal to an acute angle? No. Okay, so I'm not even going to start off with that. I'm not even going to deal with part B. Second part A. When we look at trying to determine something true or false, conditional statement true or false, we need to find counter examples to show something false. Okay. You might be a person that comes up with 200 different places, 200 different situations where the conditional statement is being shown to be true. There might be one scenario somewhere that you're not thinking of that is actually going to make the thing false. Does that make sense? Okay. And it's hard, and I understand that's hard to initially think about that. One of them that you saw, I think it was in question 5. I think I got it on here somewhere. Yeah, this one here. Okay, two parallel lines do not intersect, and they ask you to write that as an if-then statement, and then see if it's reversed. Okay, it says two parallel lines do not intersect. Okay, so I wrote that as an if-then statement. If two lines are parallel, then they do not intersect. Would you agree with that? Okay, and we say that's true. Okay, that's part of the definition for parallel lines. Two lines are parallel, and they do not intersect. It's not a definition; it's more of a characteristic right now of parallel lines. Here it says if two lines do not intersect, then they are parallel. Okay? And a lot of people put true, but that is actually false. Okay? Think about all the lines that do not intersect. And this is kind of maybe the problem that we develop with having 6th grade, 7th grade, 8th grade math that talks about geometry. It's because you were taught at those ages, hey, they don't intersect, we call them parallel, right? Okay? But what we're thinking here, because there's no distinction on all the infinite different ways we could think about this. If I look, let's just go. I'm going to create two lines here. I'll just make them. Can I do it? No, I can't do that. Grid. Two lines that are parallel are going to have the same slope, right? So we talked about last year. So those two lines are parallel. Okay, I'm going to tell you those are parallel. So that's what we start off with. They do not intersect, right? Okay. So going back to this phrase here, if two lines do not intersect, well, we've got two lines here that do not intersect, right? Then we could call them parallel, right? But what we're forgetting to think about is that's what the way we think about it in 2 dimensions. We can think about it in 3 dimensions as well. Okay? Now if I look at this, oh, I don't like that. If I look at those, would you consider the black lines never intersecting?
Yeah.
Okay, but those black lines are not parallel. Does that make sense? Does anybody remember what those are called? Talked about it like the first week of school. We mentioned it.
Skew.
Those are skew. Good. Okay. So we've got skew lines here, which we do not call parallel. So if two lines do not intersect, then they are parallel. That's false. Because if they do not intersect, the one counterexample is what happens if they're skew. Does that make sense? Okay. Once we say that a statement, if then statement is true, then it's always true. It's 100% of the time true. And we are on the task of trying to find one instance where it's false. My hope is that you guys understand that is a hard thing